Okay, let's continue. In my previous video, I made it clear that I prefer the term median over neutral, but I also posed the question, could there be an even nicer, more precise name for this conductor? Okay, I talked about that. Now, the neutral that everyone's familiar with, or most people are familiar with, is the one that originates in the secondary coil of the distribution transformer. That's the ordinary neutral that people talk about or refer to, okay? Then I showed that there is indeed another slightly technically different neutral that originates in the post-transmission transformer, all right? And that's what I call a median, but you can call it a neutral. You see this neutral, this version, originates in this post-transmission transformer, and the one that you're familiar with ordinarily originates in the distribution transformer, okay? So those are the two neutrals, and they fall within your electric power transfer system. That's what I call it. And I'll make a video on this very, very soon and explain how I cleaned up the whole system, fixed all the names, changed some of them, and made it very easy to understand and easy to learn. I want to mention here that the two medians or neutrals in question here in this video and the previous video, okay, they are connected to ground. They are connected to ground, but that's a whole different topic, a whole different discussion, and it doesn't really do any harm to what we're talking about today. It doesn't affect what we're talking about. What we're really looking for today is there an even better name for this conductor and this conductor than median? Median's very good, but is there even a better name than that? While the neutral versus median debate goes on, we can ponder an interesting question. Could there be an even better name for the neutral or median conductor? Each of these two examples shown thus far were created slightly differently, but do they function slightly differently? Okay, what are the functions of the respective medians or neutrals, whichever one you want to call them? So the neutral median from the post-transmission transformer, which comes before the distribution transformer, okay? That neutral carries unbalanced current. That neutral provides a fault path, and that neutral carries harmonic distortion-induced current. And that's because they used the Y-configured coils. Okay, it makes a like harmonic frequencies. In other words, if you have a 60 hertz frequency, there'll be other harmonic frequencies going along with that. It's just like in the music realm, the thing called the harmonic series, which you see in my videos, my music videos. In the harmonic series with music, you have the same effect. You have what's called harmonics. So that's what the neutral or median from the post-transmission transformer does. That's three things that it does. Now, what about that neutral median from the distribution transformer, the one that you're normally familiar with? Well, that carries unbalanced current. It provides a fault path. It provides a return path for the current, and it provides a 0-volt reference point. So you see these two medians or neutrals, whatever you want to call them, they function slightly differently, okay? Just slightly differently. We see that the two neutral medians in question are created slightly differently and function slightly differently. Yet we can see that they have two critical features in common. Each respective neutral carries current when loads are unbalanced. That's very, very important. And each respective neutral, or median, whatever you want to call it, provides a fault path. That is, current from the transformer must return to the transformer. Any current that leaves your transformer outside, that leaves and comes into your home, it has to go back, and it will. Even if it has to go through the earth, the soil, it will go back to that transformer, and nothing can stop it. Okay? Both of these common functions suggest not only safety, but also balancing. This is very, very important. And in my study over the years, I found out that even though they're created differently and function differently, there's a key term here, balancing, that's really, really critical, okay? So, you call it a neutral, I call it a median, and we're talking about the other neutral. We found out that there's not just the traditional common one, but the other one, right? So, logically then, what can we conclude? What would be the name, the electrical term, that conveys the most important common quality of these conductors? Well, there it is, balancing conductors. All right, balancing conductors. You have, if you want to get really technical, you could call it primary distribution balancing conductor, or the nickname could be just primary balancing conductor. Very, very simple, yet concise. And then you have your secondary distribution balancing conductor. And the nickname or the short name could be secondary balancing conductor. And that's the whole point of these two videos. I like the term median. I've been using it for a long time, but they're actually balancing conductors. They don't balance, but they provide a means for balancing to happen, and that's a beautiful thing. So that's what I call them. I call them medians, but they're actually balancing conductors. Now, soon I'm going to make a video and talk about the electric power transfer system. That's how electricity gets from the power plant to your home. I talk about everything, and I'll talk about all the different stages here. All right, there's 4, and the different steps. I kind of invented a step system. And of course, you know from previous videos that I love the word station, and I use stations in my system always. I'll talk about that, and hope you find something in there valuable and useful. So that's it. Balancing conductors. Thanks for being incredibly patient, and we hope to see you soon. Good night.